Hey guys, Mrs. Doherty here. Today we're going to talk a little bit more about weather, and you are going to need to write these down, very similar to how we did that diagram for the water cycle, but this is going to be some notes that talks about factors that impact weather. So let's go ahead and write that at the top of our paper. I'm going to make that a little bit bigger. All right, factors. And weather, hold on, I can't write and talk at the same time. What am I thinking? All right, factors that impact weather. Now, we're going to hear another term later in this unit, but we've actually talked a little bit about this previous term already when we talked about ecosystems. Because if you remember, we said ecosystems were grouped by their climate, which is a general weather pattern of a region. Well, weather and climate is very different because climate is not always changing, right? It's a pattern, so it's established. You sort of look at the weather trend or data for a location, and that's how you've determined what the climate is. But in this case, weather, we're going to define as this. So let's write it together. Weather is the condition of the atmosphere in a certain place at a certain time. It is always changing. Always changing. So, if I were to ask you, since we live in North Carolina, can you predict what next summer's going to be like? You would say, well, yeah, because we know it's usually quite hot, it's humid, it usually gets into the hundreds once or twice with the heat index. But if I said, okay, you have to tell me what next August 15th is going to be, that would be impossible because that's our weather. And our weather is going to change depending on the cloud cover and if we're going to rain that day and what kind of wind is moving up the coast. And we'll talk about all those things and how they impact weather a little bit today, but in future lessons as well. All right, so weather, always changing. All right, now we're going to talk about 3 specific things that also impact the weather of where we are. All right, I'm going to pick a new color here. All right, the first one that's going to impact our weather is temperature. Now, I know we typically think of temperature as how hot or cold the air is or something is, right? But in science terms, we refer to temperature as this. Temperature is the average speed. Oh, the A and the V are kind of connected. Let me erase that a little bit. Okay. The average speed of particles All right, your first check-in word today is going to be particles. So later when you get to your form, when it asks for check-in 1, that will be your answer. So that's your first check-in word, particles. So temperature is the average speed of particles in a substance. So some things that temperature can do, well, it can change how warm or cool air feels. And another thing, temperature is different depending on the type of surface that we're talking about. So land and water both absorb heat from the sun through radiation. Remember those heat transfer methods. So land and water absorb heat from the sun and I'm going to put radiation. Okay? So land and water absorb heat from the sun, which is that radiant heat, radiation that comes down. Now I have to change my whiteboard out, so because I wrote too big, but I'm going to keep my color so we know this still goes with temperature. But the land heats up faster than the water, and it loses heat faster too. You have probably experienced this if you've ever walked on sand at the beach. When you're walking on that sand, it is super hot, right? Because all those little particles of sand are heating up, and it's way hotter than if you put your feet in the water. Now, obviously, an ocean is a ginormous body of water, right? So it does take a long time for that to heat up. But the same is true if you think about the fact, like if you put a little kiddie pool in your front yard filled with water, and then you stand on blacktop right next to it. That blacktop surface, that rock surface, is going to heat up much more quickly than the water is. But later in the evening, the water is going to retain or hold that heat a little bit longer, whereas the rock can't really hold on to that heat. So if you think about if you've ever gone to the beach in the evening, how much cooler that sand feels so quickly from hours ago when you were there during the daytime and it was burning your feet. All right, so temperature. Temperature is definitely a factor for weather. All right, I'm going to go to a new whiteboard, and we're going to talk about a different concept. I'm going to pick a different color. Let's see. I will do red for this one. All right, the next thing that is a factor for weather is wind. Wind, wind, wind. A whole lot of time talking about some wind. So wind is moving air. No shocker there, right? Wind is moving air. But it's caused by something really interesting, because if Earth did not do this or have this, I guess, problem, is it a problem? I don't know. But we wouldn't have air moving. So wind is caused by the uneven heating of Earth's surface. Now, if we could heat Earth evenly, we wouldn't have any wind. Caused by the uneven heating of, oops, that should be a V. Not a V. What am I talking about? It's Friday. My brain is gone. It's an F. The uneven heating of Earth's surface. So if we could heat everything evenly, we wouldn't have any wind. But because Earth is rotating and it's slanted, that slant creates areas where some is getting indirect heat and some is getting direct heat. So for example, the equator belt of the Earth gets a lot of direct heating. The poles get very indirect heat, and so they're cooler. And because of that warm and cool difference amongst the Earth, we have all these different wind belts that happen to pop up. All right, wind blows.
Yeah, I guess I was texting back and forth with Ryan last night. I guess
from areas of, and I'll talk more about this in a minute, high pressure to areas of low pressure. So high pressure air is going to be denser and a little bit cooler. Low pressure air is going to be warmer and a little less dense. If you imagine you've got like a big test you're studying for, right? You're under a lot of pressure, a lot of stress, and you want to get to low stress, right? So high to low is how it goes. That's what I use to remember it. Our check-in word number 2 for today is pressure. Pressure is our number 2 word. All right, one more thing to do for our notes today here. So I'm going to switch over to a new whiteboard. All right, air pressure. Air pressure is the push of air against objects in all direction. Against objects in all directions. All right, so there's going to be 3 things that affect air pressure. So I'm going to go to a new board so we can kind of do one at a time. So the first thing is going to be the temperature. Warm air has low pressure and cooler air has high pressure.
Well, I mean, AAR is really the only one. I mean, occasionally go do something to grab, and then once in the blue moon for
That's my clock, if you can hear it in the background. All right, so temperature. Warm air has low pressure. Cooler air has high pressure. The next thing for air pressure is the altitude. The higher the altitude, the lower the pressure. Now, this is a little bit funky. The reason it is because there's less air above you as you go up into the atmosphere. So it is cooler up there, which is true, but there's less air. So we either look at it as temperature or as altitude when we talk about if it's low pressure or high pressure. So altitude, the higher you are, the lower the pressure. All right. And the last one would be water vapor. So water vapor. All right, guys, I need to switch to a new video because YouTube only lets me load 15 minutes. So I'm going to stop this video and I'm going to pick back up on the second video here in just a minute.